Well, this is the week 4 lecture on z-scores and normal distributions. So I'm hoping that you will enjoy the lecture, and if you have any questions, obviously as usual, please give me a shout. This is what we're going to do. Before we even get going, we're going to do some review of some of the stuff that we had last week. And this is actually for another question that I asked another class, but we'll go through it. Let's say we have a group of the following observations. We have a 0, a 10, a 30, a 40, and 2 80s. All right, so let's figure out the mean. The sum of x divided by n. Let me just grab my pen here and jump right down here to the pen mode so I could write with you. So the sum of x divided by n equals 240 divided by 6, so the mean equals 40. The median is 30 plus 40 divided by 2 equals 35. And you remember what happens when it's a how many, go right back up here and count 1, 2, 3, 4, 5, 6. It's an even number. Okay, so we could split the middle right down here. If it was an odd number, we'd take the average of the middle 2, if you recall. The mode, well, we have 2 80s, so that's going to be the mode. It's just the most prevalent number. The minimum is 0, as you can see right here, and the maximum is 80. So that's going to be our range, okay? And I'm just going to hit the next key. Let's say we have the following observations in a given sample: 0, 10, 30, 40, 80, and 80. Let's go ahead and put those x scores right. Sorry about that. Right in the. I'm not writing any longer. I'm going to grab this pen and let's go ahead and put them in a table. So we're going to go ahead and put them in a table. And the next thing we're going to do is we're going to compute the mean, so the mean for this distribution is the sum of x divided by n equals 240 divided by 6, and as we said before, the mean is 40. The next thing we're going to do to compute the deviation score, we're going to compute the deviation score. We take x minus the mean for each one, so that's 0 minus, what was the mean? It was 40. 0 minus 40 equals negative 40. 10 minus 40 equals negative 30. Oops, sorry about that. 30 minus 40 equals 10. 40 minus 40 equals 0. 80 minus 40 equals 40. And 80 minus 40 again equals 40. Let's pop over to the next screen, and we're going to square each deviation score. Okay, so x minus m squared, and I'm asking down here, why are the deviation scores squared? Because a distance can't be negative. All right, remember that. We want to get rid of the negative numbers. So we simply, to square, if your calculator does squares, just go ahead and use that function. And if it doesn't, just simply take the number. So it's negative 40 times negative 40 right here, as you could see. Oops, sorry. I'm wild with the mouse tonight. Negative 40 times negative 40 equals 1600. Negative 30 times negative 30 equals 900. Negative 10 times negative 10 equals 100. 0 times 0 is still 0. And 40 times 40 is 1600. And 40 times 40 again is 1600. So you remember they're all positive numbers now. All right, we have no longer to deal with any of the negative numbers from before. So step 4 is sum the squared deviations to obtain the sum of squares. All right, and the sum of squares, we're just going to go ahead and we're going to sum them. So we just add them up. So 1600 plus 900 plus 1000 plus 0 plus 1600 and 1600 equals 5800. And step 5 out of the 6 simple steps to complete a standard deviation is compute the variance. How do we compute the variance? We take the sum of squares divided by n minus 1. Don't forget, it's a sample. If it's a population, we don't use n minus 1, we use n. And that equals 5800 minus 6 minus 1 equals 1160. So we're simply dividing 5800 by 5. And the standard deviation equals the square root of the variance. So we take 1160 and take the square root of that, which is 34.06. Pretty easy, isn't it? Let's try another one. Let's say we have a distribution of 60, 90, 90, 100, 120, and 140. Do this with me. Let's figure the mean. The mean is simply the sum of x's, so we add all these numbers up. We divide them by n. 1, 2, 3, 4, 5, 6. Here's your 6 equals 100. The median, don't forget, we have 1, 2, 3, 4, 5, 6. It's even again, so we divide by 2 and come up with a median of 95. And you know how to do this in SPSS, and if you want to check your work, go ahead and do it right in there. The mode, what do we have more of than anything else? We have two 90s and only one of each of the others, so 90 is the mode. The minimum is 60 and the maximum is 140. Let's say we put them in a table because they're easier to work with, and we'll do step 1. We compute the mean, which is 100. We then compute the deviation score. We take each x and we deduct the mean. So 60 minus 100, that 100 is the mean, remember, is negative 40. 90 minus 100 is negative 10, etc., etc., etc. Just go ahead and work these down. You could put it on pause, and as soon as you confirm that each one of these numbers is right, pop over to the next screen. Step 3, we're computing each deviation score. So we're taking x minus the mean squared, all right, to get rid of the negative numbers, and we come up with 1600. The step 4 is we sum the squared deviations to obtain the sum of squares. So just add them up, and we've just squared everything. Just add those squares up. We come up with a figure of 3800. And step 5 out of the 6-step process to compute a standard deviation. And don't forget, the standard deviation is going to lead right into z-scores, which we're dealing with next, okay? That's why I'm reviewing this. We're going to figure the variance, which equals the sum of squares divided by n minus 1. You tell me why we're using n minus 1. Because it's a sample, not a population. What do we do with a population? That's right. We use n instead of n minus 1. So 3800 divided by 5 equals 760. Popping over to the next one, here comes the standard deviation. It is square root of the variance is the square root of 760, which we obtained in the last screen, equals 27.57. That's the standard deviation. And just remember, positively and negatively skewed distributions are going to have the mean and the median and the mode in different places. Just sketch them out. What is this? Do you remember what this is? Could you tell me, is this negatively skewed or positively skewed? It is. To figure out what a positively skewed distribution is just to remember, we always start at 0 and we head up on the right side of the x-axis. So it's where the tail is. It's where the tail of the distribution is what so this is a positively skewed distribution because the numbers are positively getting bigger as we proceed to the right of the x-axis. So in a positively skewed distribution, the mean is going to be bigger than the median, which is going to be bigger than the mode. And don't forget, in a normal distribution, these things are all going to be in the same place. In a negatively skewed distribution, which is over here on the right, B, the mode is going to be bigger than the median, which is going to be bigger than the mean. And that's just the way it is. Okay, it's always going to be that way. So as a cheat sheet for when you have to know this, for instance, on an exam, hint, just take a positively skewed distribution and put mean, median, and mode, and take a negatively skewed distribution and put mean, median, and mode. All right, and the mean is always going to be closest to the middle. All right, of the two images that you draw. Okay, moving to the next screen. So last week's review. Because IQ tests or standardized IQ scores follow a normal distribution with a mean of 100 and a standard deviation of 15. Between which ranges of scores would you expect to have roughly 68% of the scores? 85 to 115. That's right, because we did 100. It's one standard deviation, so we deduct 15 from 100, and we get 85, and we add 15 on the other side and get 115. Roughly 95% of the scores, we're going to be deducting 30 because it's approximately 2 standard deviations, and adding 15 times 2, which is 130, which is approximately 2 standard deviations. What's the standard deviation here? You remember, it's 15. And 98% of the scores, what is that going to be? 3 standard, about how many standard deviations? That's right. And so you're going to go down to 55 and up to 145, about 3 standard deviations. Okay, so that's the rule, the empirical rule, if you recall. And key concepts this week we'll be talking about in the next slide.